This note is from CUHK, a very old note already. And then it contains most of the mathematics you need for the calculation. Now, first of all, you can skip what if I didn't talk about that, okay? You can skip that one if I didn't talk about that. First of all, you need to know the definition of sine x, cosine x, sine x, okay? Hyperbolic sine, we pronounce it as hyperbolic sine, and hyperbolic cosine. And then we may need to use these two actually in some cases. And also, the x or the z can be all numbers. It can be a complex number or even a matrix inside the formula. So you may wonder how we define an exponential to a matrix. So we know that from exponential can be written as this formula by the Theta expansion. So we will talk about the Theta expansion soon. And then, so if X is a matrix, okay, you just put it into here. But of course, one you need to convert it into identity matrix. And let's say the matrix is like this one, okay? And so on so far. So it can still apply for if X is a matrix, it still apply. And then so this is a definition of sine z and cosine z. So what is the derivative of this one?
呢個咪普通嗰個 derivative，唔一樣。咪 h cosine。
So it will equal to the hyperbolic cosine z, okay.
Okay.
If you differentiate the hyperbolic cosine, then you will get the hyperbolic sine. Okay.
Yeah.
Or if you differentiate once more, you get back yourself. Therefore, actually, if the equation is look like this one, just like if you differentiate y twice and then give you y.
Yeah.
So the solution can be hyperbolic sine or hyperbolic cosine. Or in general form, it can be written as this one. And also there's something you may need to remember. So what is the value of hyperbolic sine 0?
Zero.
How about this one?
1.
Just so similar to sine 0 and cosine 0. And I don't give you don't bother this question, okay? You just need to substitute in the formula and try to expand it. Also for this one, if you want to prove this one, it's much easier if you use the mathematical induction. Mathematical induction. Then we skip it, okay? Not too useful. So we have talked about the Cartesian coordinate to polar coordinates. So let's have a look at the cylindrical coordinates. Also, cylindrical is actually equal to polar plus a z-axis. And then the unit vector in the in the new coordinates, rho, theta, and z. But why we use the symbol rho instead of r, right? Because we often use r as the distance from the point to the center or to the origin of the coordinate system.
Mm.
And rho here is the radius of the cylinder.
Mm.
And then next one we will talk about is the spherical coordinate.
Mm.
Now it's so difficult to actually there's 3 coordinates. We use one distance and 2 angle to represent a point in a spherical coordinate.
Mm.
R equal to the distance from O to P. And theta hat, now first of all, you need to define one point first. Now the points P will project on the XY plane vertically, okay, to form a point P pi. P pi. This is origin. And then the theta is defined as the angle between the x-axis and the vector OP pi.
Mm.
Phi is the angle, right? That's defined between the z-axis and the vector OP.
Mm.
Just something you need to remember. In some of the textbook, they use phi to represent this angle and use theta to represent this angle. So it really depends on which textbook you are using. So that you need to read the textbook by yourself, okay, to see what the notation it is. But the textbook we use soon in the electromagnetism, actually they use the notation that use the phi represent this angle and theta represent this angle.
Mm.
Then you need to remind yourself is how we define the theta and phi. Sorry, what is the range of theta and phi? The theta is defined in between 0 degree to 360 degree.
Mm.
Of course, excluding the 360 degree because it is just represent the 0 degree.
Mm.
Then how is the angle phi? What is the range of angle phi?
Mm. 0 to 360.
No. It's just 0 degree to 180 degree.
Oh yeah. Mm.
And then they will if you consider the phi, let's say if the phi is 270 degree, that means you can minus it, and then your theta will convert to theta plus 180 degree.
Mm.
Actually, these are all written here. And this is quite similar to how we define the longitude, altitude, I don't know, in the map about a location. But the definition is quite different. So the angle in geography or the map, they use this angle. They are not using this angle.
Oh.
Then let's see how the theta hat and then the phi hat is defined in the spherical coordinates. So theta hat is defined as the direction when the theta is increasing.
Mm.
Then phi is defined as the angle phi is increasing. So phi hat is parallel to this plane.
Mm.
And then tangent to this, how can I show it? Tangent to this arc. and point towards to the direction when the phi is increasing. Just ignore how we convert this coordinate system. Otherwise, it's so complicated. So about the cone excitation, we have talked about it a little bit in the conversation about and we will look at how to prove it later on, this formula. But we have talked about this in the conversation. You can just skip those topics that I haven't talked about, okay? So let's, but if you are interested, okay, you can look at these content. I think I don't need to talk about what is meant by geometric series and then the arithmetic series. So then let's go on to about the ODE, ordinary differential equation. Later on, then we'll look at the PDE, that is partial differential equation. So what does mean by differential equation? This is just the equation with containing the derivative. That's it. So first of all, we look at the first order differential equation. Now, for differential equation, just like the integration, there is not always a solution. So does the differential equations. You may not be able to find a solution for a arbitrary equation. And then we look at how, so this one is, so we can solve this easily, okay, by taking integration on both sides. And then let's have a look at the first type that we need to know how to do it. You will see it very often. Separable variables. The ordinary differential equation in this form. In the form like this one, okay. Fx divided by gy or times gy, it doesn't matter. So what we do is that we multiply the gy on here and then multiply the fx in here. And then we take the integration on both sides. And then on the left hand side, it is a variable of y only. On the right hand side, there is a variable of x only. Then we have solved the equation already. But we can't directly take the integration from this equation because we don't know how to express y equals of x yet. Then you try to do one of the question, okay? Let's see, okay. So you may have a look. Why there's no questions? Okay, so you try to solve A1, one I.
Should be e to the power of x equals to negative e to the power of negative y.
You ignore one vector is plus c. And when you take the integration, you always need to plus c. 你咪有呢個 sign here?
Yeah.
Okay. And then try this one.
It's like ln log y equals to log x plus c, but then so y is equal to equals to, wait, let me, y is equal to x times e to power c. Well, y equals c cx.
Yeah, but the c are different c, okay?
Yeah.
Then x plus 8. And then so you can put it with kx. Let me ask you one question. So when you say len A to len B, okay? Why you can say A to B? Let me give you one example, okay? Let's say if you say sine theta equal to sine phi,
Yeah.
you can't say theta equal to phi.
Yeah.
But why you can say so in the len?
Oh, because like it's like a unique solution. It's not a periodic
But
function.
why? But yeah, there's only one unique solution. But what properties of the len x give you this? Give you a unique solution? Actually, in mathematics, we will say that because len x is a monotonic increasing function.
Oh.
So for every y, there is only one x corresponding. So there is only one unique solution. So there are some other type of question. You need to change of the variables, just like this one. Now, if they give you the form like this one, it's already very kind to you already. If the question have deleted the x, y, just like this one, right? Then it may be very difficult to solve it. No, actually not difficult. So can you try to solve this equation by using the separation variable?
Wait, the right one?
Actually, they are equivalent. You can see. I just cancel out the x, y on both sides.
Oh yeah. Y is equal to x to the power of -2/3
Is there a constant there?
plus. Oh yeah. Let me. So this y equals to kx to the power of 2/3.
So they will give you the same answer, okay?
Yeah.
So you may read this part by yourself. Okay? There's another type of solution. If you can written like this form, you can substitute a variable and then try to solve it.
Oh.
But it's not so often in physics. So we can skip that part.
Oh. Okay.
So look, let's have a look at one very special type of the first order linear differential equation. And this one now, you may need to use it, but not so often. But if you don't know how to use these skills, normally you can't solve the equation. So, and then if you look at this equation, any equation with this form, actually there is a method to do it. So let me write down the method on the left-hand side. Did they teach the differential equation in the tutorial class?
They did, yeah.
They have?
They taught ODE, systems of ODE last week, I think.
Oh, so
yeah.
you should have learned all of this already.
Yeah.
How about this one?
Not integrating factor.
Okay, not this one.
Yeah, didn't teach it.
But they should have taught about the separable variables.
Oh yeah, they did. Yeah.
Because it's the easiest type, and also the most common type of differential equation in physics. So first of all, we need to multiply to the mu x. That is called the integrating factor on both sides. And then this is a function of x. And then we don't know how the mu x is defined. We just multiply it first, and then we try to expand. Try to expand this bracket. So we try to multiply mu x on both sides such that the left-hand side can be expressed in terms of this form.
Oh, like product rule or something.
Yeah. So if you look at the product rule, okay, the first part, okay, if we expand this one, the first part are the same. Then the second part, they look like the same, but you need to you need these two parts to be equal to each other.
Mm.
Right? So the mu pi x equal to mu x times px. So let me shorten the mu x by mu. So you can use the separable variables to solve the mu.
Oh, yes.
So it is exponential to the power integrating the px dx. Now you may wonder why I don't put the plus c here. So let me write down the plus c here. So if the plus c like this one, that means there's a constant multiple this one. Actually, if you look at this formula, the constant k doesn't matter because on both sides they are constant k.
Mm.
They can be cancelled out.
Mm.
Therefore, the value of constant k doesn't matter. So normally, if you know this method very well, we don't put a constant k there. We just put it like this one. So then the next step, we're trying to differentiate this one. Equal to qx times this one. Now, whether you can integrate it or not, it does. It's a matter of this question, or it's a matter of your skill. Then right now you can solve the equation already.
I want to ask, how do you go from this part to this part?
So you put this one to the denominator.
Mm-hmm.
Integrate on both sides.
Yeah.
Mm.
Oh.
See if you still have any question here.
Mm. Yeah, I don't have any questions.
Mm. Then you can try to do one question by yourself.
Okay.
Kill the screen now.
Okay.
So you try to solve this one. Or you can just give me the answer. You don't need to write down on the screen.
Oh, I think I did something wrong.
Mhm. So you may show me the step in WhatsApp.
Yeah, I will.
So maybe let me show you some of this. Now what you need to do, first of all, you need to put the y on the left hand side.
Mm.
And then multiple by a mu on both sides. Such that this one can be expressed as the derivative of mu times y. And then when you expand this one, you can see that the mu prime should be equal to negative mu. I think that's what you have done already.
Yeah.
Then you can solve that the mu should be exponential negative x.
Yeah.
And you put back in this equation, this one.
Mm.
And then you try to integrate on both sides. So first of all, do you know how to integrate this one?
By parts.
Yeah. Then you try to finish it.
Yeah. So it should be c times e to the power of x minus 1.
So can you written down?
Oh, okay. Should okay, yeah.
C times. Okay, so how will I check the answer? I'll just differentiate once.
Oh,
Check it by substituting the formula. So you can see that y plus x equal to y prime, okay? That means your solution is correct, most likely, okay? And also remember that if there is one, if it is a derivative to power 1, then you have, the solution should have one arbitrary constant. If it is a second order differential equation, you should have two arbitrary constants. So far. So and then if OK 的話呢 and then you can try to do about the initial value problem. That means you need to substitute this value to find the solution. Find arbitrary constant. Okay, that should be quite easy. And then for second order linear equation, it's not that lucky. We don't have much solution on that. We can solve only a several type. Actually, we can only solve that the coefficient is a constant. But so let's first of all, let's have a concept about the homogeneous equation. So what does mean by homogeneous equation? Actually, it means that the order of y is only up to power 1. Power 1. There is no y square, psi y, or exponential y term in the equation. And then the very important thing about the homogeneous equation, homogeneous differential equation, is that if y1 and y2 are solution, then a arbitrary constant times y1 plus an arbitrary constant plus y2 is also a solution. Do I need to prove it?
Can you solve equation with like x times y or something like x times y dot plus something like that? Can you solve it?
Can you write down the equation again? Which one?
I can't. Let me think of an example. Yeah, actually, I forgot the example. Anyways, I'll tell you later.
Okay.
Yeah.
So and then if it is obvious then I don't need to prove it. Okay. To think it's obvious.
Oh yeah, it's pretty obvious.
Okay. So then we can skip the proof. So then let's have a look at this one. Show that this one and this one are also solution of the equation.
Oh.
Which are linearly independent. We also need to talk about the linear independent. What does mean by linear independent? Let's say if fx and gx are linearly independent. It means that afx plus bgx equal to 0 if and only if A and B are 0. Of course, let's say I give you one example. If x is squared plus 1 and 2x is squared plus 2, they are not linear independent because we can find a set of A and B such that they are not 0, and which also satisfy this equation.
Mm.
And then EX and then E exponential x, of course, they are linearly independent. In mathematics, you need to use a Wronskian. Forget the name. We call Wronskian. Yeah. To show that these two are linear independent. You can look at the proof later on. And then I think it's not difficult to show these two are the equations. If these two are the equation of this equation, then y can be written as a times exponential x plus b times exponential x.
Mm.
Okay. And now I also told you that we have also proved this one actually. This one differentiate twice, you give back itself. This one also.
Mm.
So actually, this equation can be also written as this one.
Mm.
Now they are actually equivalent, but sometimes we may prefer one than the other. Let me give you one example. Let's say if I given you one initial condition, when x equals 0, y equals 0. Okay, if you use the first equation so you substitute y equal x equals 0, y equals 0. So it gives you 0 equal to a plus b. Okay, then somehow you can simplify the equation like this one. That's still fine. Okay.
Mm.
But if we are using a second equation, so when you substitute in the formula, so what you get is 0 equal to cosine h 0 is 0 is 1. Okay, so you get c equal 0. Sine h 0 is 0.
Mm.
That means that the equation can be simplified at this one. This one looks like much better. And actually, it will be better if you want to express some of the solution. Let's say if you want to say when y equal to, let's say find x, okay, something like that. So you can use this one You can use the arc hyperbolic sign to get the answer directly.
Oh. Mm.
So I clear the screen now.
Right. Yeah.
And then let's go to, don't need to talk about this one. Then we are going to solve one very special type of second order differential equation. So let's say we have a type of second order differential equation with this form. Then, first of all, this one is homogeneous.
Yes.
So in physics, we will try to find a solution. So let's try y equal to exponential rx. So y pi equal to r and y prime equal r squared e rx. So when you substitute in the formula, the second step I can do is cancel out the y. Now, why you can cancel out the y because ERX will never be equal to 0.
Yeah.
And then you can see this formula is very familiar with you should be very familiar. This
Yeah.
is conformal equation.
Yeah.
So let's say if we can write down the then we need to have 3 different cases.
Oh yeah.
And that means one solution is alpha plus beta, another solution is alpha minus beta. So for the first case, second case, and third case. So for the first case, it is when the discriminant is greater than 0.
Mm.
Then the solution then will have the final form like this one. So, yeah.
Mm.
Of course, you can take out the E alpha x from the equation. Actually, they can also write down it in another form using the hyperbolic sine and hyperbolic cosine.
Mm.
And then the A and B are not the same here. And then the second one is when this is 0, 0. The solution may be look like quite weird, but the solution is have this form.
Mm.
The third case is when this is smaller than 0. Actually, it can just be paste beta with I beta from this form, okay? Then you can get the solution. They are the same, actually. And most likely, we will write down the solution in terms of sine and cosine. Just like this one. Okay. So we can save the screen, okay, and then
Okay.
and then you try to find the solution of these 2 questions. Yeah.
Okay.
How about the next one? The next one.
It's 8 o'clock.
Okay, then I think that's the answer. Okay. So if no question, then let's go on. So actually there are several different kind of method to solve the differential equation. Oh, sorry. We also need to talk about this part.
Oh.
This will also be in the test. So this one is very, very important. So let's say if the solution, if the differential equation have this form, so then the solution of the y contains two parts. One is the homogeneous solution. One is a particular solution.
Oh.
For the homogeneous part, that means this is a part when you are solving this one.
When gx is 0.
Yeah. Just consider as if the gx is 0.
Oh.
And then for the particular solution, is trying to find a particular function with no arbitrary constant, such that this equation is balanced. Yeah. So actually, there is some room for you to try the particular solution. So let's say if the gx is a polynomial to the power n, then you need to try a polynomial to the power n also, but with different coefficients. Okay. So let's say if it is a polynomial times a exponential exe, then you need to try the polynomial of the same order times ekx, just like this one. Okay. So let's try to do the first one. Okay. You just try to find a particular solution. So we will try the particular solution to be ax plus b. Okay.
Okay.
A plus b. So if you differentiate once, you get a. Differentiate twice, you get 0. So if you substitute in the left hand side, what you will get is negative 2a plus ax plus b equal to 4x plus 2.
Yes.
And then you compare the coefficient, and I think you can get the answers very soon. Yeah. That means the particular solution should be 4x plus 10. That's it for first part. So how about the second part? Can you try to do it by yourself? Yeah.
Well, I'm not sure how you guess. Do you guess
So if you look at this form, the polynomial is just 2, okay? So you should guess the form like this one and find A.
Oh, yeah. I see. 0.4.
0.4. So it should be like 2A plus 2A plus A equal to 2, okay? That is 0.4, okay? So, and then let's have a look at part 3. Actually, we can separate the this one into 2 parts, actually. So we can solve one part by one part.
Oh, okay.
Because it is a homogeneous. It's no, the first part is homogeneous because
Wait, what do you mean by solve by 2 parts? Like,
so you just consider the particular situation of this one and particular situation of this one.
oh, okay.
Part by part. Yeah. And we will encounter this kind of problem later on in solving the SHM problem.
Oh, yeah. don't know what I did wrong for the sine 2x solution.
So for sine 2x, haha, this is the most special part. So you may look at this passage. Yeah.
Oh, what's YC?
Hmm?
YC. This one.
See
This one.
which one? Oh, I think they say complementary, whatever. This is, it means the homogeneous,
Oh,
but they use another name for it. Actually, you won't encounter this kind of solution very often. So you can try to ignore it. So I save the screen and then let's go on.
okay.
Let's go to the next part. So this part about the matrix. So if you are not so familiar with matrix, you can have a look at it. Because when you are trying to solve the system of linear function, yeah, you need to use the matrix.
Okay.
Okay. So and then so you may need to read it.
Can you use matrix in second order or first order?
First order, no need to use matrix.
Okay, a second order.
And then for second order, yes, you may, if it is a system of linear equation. So then let's have a look next. So this is about the partial differentiation. And then this is some of the notation that you need to know. Okay. It's no problem. Let's go on.
Okay, no problem.
So and then now these two will be equal if they are both continuous at any point.
Oh, yeah.
Or you can say the first derivative, fx or fy, if they are continuous, then these two will be equal. And this one is the total differential.
Okay.
To prove this one, you can look at this graph or That's how we define the dz. Z is a function of x and y. So it means that the fx plus dx, y plus dy minus fx y. So we can insert one part in this equation. So for the first part, actually, it is the partial derivative when y equal to y plus dy, okay?
Okay.
On dx. So the second part is a partial derivative. One y okay, dy here. So when dy and dx tends to 0, then they will give you this form. Sometimes it may be useful, but let me give you one application that is very useful to learn when you are doing some question. Okay. So let's say if you are given a function like this, just make it up, okay? Just something like that. So I just make up the equation. So let's write down let's define fx to be the form like this one. So fx will be equal to 0. So what I do is minus x squared y here, okay? That or constant, okay? Either 0 or constant. So and then we define. Sorry, this is fxy. Okay. Then df can be written as 1 f over 1 x dx plus 1 f over 1 y. Actually, in English, we call it partial f, okay? I just say in Cantonese, okay? 1 because it's 1, okay? And then dy here. And because f is a constant or 0, so that means a change in f is always 0.
Yeah.
Get one very important formula.
Oh, change in f is.
Yeah. Because f is always 0.
Yes.
Like this one. So what is the use of this one? This equation can help you to find the implicit differentiation more easily. If you want to find the derivative of dy over dx in this equation, it's so troublesome if you are using the ordinary method. If you are using the partial differentiation, it's always easier because you don't need to take care about another constant when you do the derivative. So I can write down I can write down the answer directly. Why I make up a such difficult equation? Like this one, okay? Then that's the solution already, okay? You know that when you are doing the ordinary method, even for differentiate this one, you need to use the chain rule, product rule. A little bit troublesome. So you need to remember this trick, okay? So when you are doing the IB question, you can use this trick to do it. So you can save the screen. Actually, I can just see this trick in a Russian textbook. But this is a very nice trick to learn. And also about the chain rule in the partial D. But actually, it's not that easy. You can see sometimes they write it like this form, and sometimes they write it like this form, like this one form. So which form it should be that? So let's talk about this one, the chain rule, okay? So what does it mean by the chain rule in the partial D? Now, first of all, the function f or the set should be function of x and y, or more, okay? Or more variables, it doesn't matter. Let's say if x and y is a function of t only. And then if you want to find the derivative of z relative with respect to t, now this one you can use the ordinary differentiation. These two are actually the same. Because you can always express the set in terms of t. If x and y is a function of t.
Oh, yeah.
And then what we can do, so there are two rows to go to from z to t. This one and this one. For the first part, this one, this is 1 z over 1x. Why is partial d? Because z is a function of x and y. And from here, from x to t, x is a function of t only. So it should be dx over dt. And similarly for another row. Okay. So another type of function is like this. Z is a function of x and y. But x and y is a function of s and t also. So you can't do the ordinary differentiation of z relative to s. You must do the partial differentiation. So you have two rows to go. So it's partial z, partial x times partial x, partial s. Like this one. Okay? Easy. Okay. Then. So that is what it means here already. Lagrange multiply is not that useful here. Actually, this course is really, really tough because you need to learn a lot of the stuff.
Oh.
There are how many chapters here? There are 9 chapters here. So that means that normally they talk about 1 chapter in 1 week. But actually, we just finished half of it in half and 1.5 hour. But for the multiple differentiation, multiple integration, we can talk about later on when we're talking about the center mass. Because with some application, then you remember this much more. So right now, these are actually these two PDF contains most of the mathematics you need for the commission. Let's talk about some special type of ordinary differential equation. Let me think about it. It seems I forget that kind of question. I almost forget. Let me see. But there's some special type that you need to remember for x dot dot. Let's say the equation is like this one. Okay.
Yeah.
It seems so weird to solve this question, but there's one trick about x dot dot you need to remember. Always you need to remember. Because if you want to solve this kind of differential equation, you always need to use this trick. So x dot dot, that means the derivative of x dot with respect to time t. So we can use the chain rule to write it. And then this one actually is the x dot. Okay. Actually, I make up this question in purpose. So x dot dot equal to x dot dx dot over dx.
Yes.
So this one is a separable differential equation.
Oh yeah, I see.
So you can cancel out the x dot on both sides. Then right now you can solve it already. So x dot equal to x squared divided by 2 plus x.
Oh yes.
And then if you want to solve x in terms of t, then this one is a separable differential equation. Let me write down as c over 2. It's easier. Okay. And how to solve this is your integration skill problem. Actually, this one should be arctangent. X is something.
Oh yeah.
Then we have solved this one already. Let me think about arctangent. T. I think the solution will look like this one. The solution may look like this one, kxe, arctangent kxe. So let's try to use this solution. Because this one is arctangent. Oh, no. There may be some constant here, okay? So complicated. Yeah, just ignore it. Okay? So you can solve it by yourself, okay? Then, so we'll go on, we'll look at some of the mechanics problem with using the ODE next time. So then see you on Friday, okay? Bye-bye.
Bye bye.